Okay, now let's look at the practical of next practical, determining refractive index of a material by the critical angle method. Okay, by the critical angle method, we are going to determine the refractive index of a material. So this is simple, right? What you do is something like this. I'll first explain the practical. Okay, so here, right? Here also you have a prism. Let's say something like this. This practical is a frequently asked one. Okay, so you should remember the points well. So you have prism like this, right? Um, and let's say you have a point like this. It's like this. Now you are going to determine the refractive index of this glass. Okay. Up to now, the light practicals we did was determining the refractive index using a traveling microscope. Using the real depth, apparent depth concept, we determined the refractive index of glass. After that, we did the minimum deviation practical. That was not something related to refractive index, right? So this is the second practical related to finding the refractive index of glass. Okay, so what we do is we keep a object pin. We call it as an object pin. Simply, it's a pin which we consider as an object. In the previous practical also, we used two object pins, right? So this is what you call an object pin, right? So here, what we can do is after we keep this, right? There's a possibility that this thing gets totally internally reflected. If so, what happens? There will be an angle, there will be a certain angle, and then here, rare, dense to rare, right? So it will go like this. At one point, we might be able to see this. Okay. So what I do is, remember this procedure, right? We actually keep our eye from this point, okay, and move our eye from here to here, right? Okay. From here, also we can see the like pin exactly, right? We can clearly see the object pin. Right? Let's say you can see it clearly here as well. You can see it clearly here as well. But at one point, it will start to disappear. That means at one point, right? Like it will exceed the critical angle. At this point, let's say it reflects like this way. But if you move somewhere here, okay, then what happens? It will go like this and it will stop the total internal reflection. Okay, it will not totally internally reflect. It will just refract. Okay, I hope you understood that. It shows that the total internal reflection up to a certain point, but after that point, it won't show that, right? So that is the point where we are sure about the critical angle. Okay. Let's say we moved the eye from here to here. Okay, let's say this is ABC. We moved our eye from here to here, and at this point, we found that it did not show that total internal reflection. Okay, so this is the point. We found that. Okay, and then at that point, right? That point, like at the point where the image object pin almost tries to disappear, right? So I written that. Yeah, it almost tries to disappear. We can place just like in the earlier practical, we can place two pins. Okay, say I placed two pins here at this angle because I know that is the point where it starts to disappear. Due to that, when it is almost just slightly appearing, I place the two pins here. Now what can you do? Now you remove the prism. Okay, because now we need to do some geometry. We just remove the prism. Now the prism. Now this is just a paper with the outline of the prism drawn. There is no prism. Okay. First step. Okay. Listen to this carefully. First step. What we should do is we should draw a perpendicular to this CB line along with this one, along with this object draw, like this. Okay. To draw perpendicular, and it should be equidistant. And we can mark a point I at this level, right? What's the first step? That's those steps are given in the note. First of all, we should draw, like we should take this BC. We should draw it like from point O to I. Uh, the perpendicular, it should be equidistant, right? From this BC line border. Then what can we do? Then we can draw a other line like this until it meets this. What was this? This was the first step. This was the second step. Now what can we do? Now we can join these two. Okay. Now we can join these two. Right. Now in this diagram, it don't come properly, right? Yeah, it's not exact, but let's look at this one. Here it comes because I haven't drawn, like my dimensions might be wrong. I'll explain you using this diagram because here, like I have drawn the eye here. This was my first step, marking this eye, equidistant and perpendicular. Then I joined this PQ, the two pins up to this BC line. This is the second step. Then I joined this R point and I point. Okay, I joined this. After I join this, I will find another point called S, which is the intersection of the line AC and the line IR. That is the point where the light ray hits. See, that is the point where the light ray hits so that you can complete the diagram. Okay. So please refer these steps once again. Back. It's no use watching this video like 2, 3, 4, 5 times. If you can't understand, you watch it 2, 3, 4, 5 times. But the most important thing is practicing. Okay. Like you should draw the diagram yourself. Try to find how you can draw a proper diagram. Do the calculation by your mind and try to get it to your mind, right? That's the most important thing. Okay. So that is what we can do. And then way to make this more accurate, right? Repeat experiment many times and get an average because it's difficult to get the exact position where the image disappears. Like there can be a human error in this reading, right? I mean, it's difficult to, like, it's sort of a not definite thing, right? So it's better to get an average. Why keep O touching the prism to avoid refraction? That's true. If we keep O somewhere here, there will be a refraction error as well. Okay. Uh, a small modification to get the refractive index of water. Like this was asked in a past paper. Like instead of glass AI interface, see, if there is a glass AI interface, what can you do? I did not complete the practical, right? Here, after getting the critical angle, what can you do? I hope you know that, okay? After getting the critical angle, what can you do? You know, if you take, let's say, a glass and air, hmm, this is the critical angle, what happens? This will go like this, right? So, sine C, the sine value of the incident angle into the incident medium, which is n glass, is equal to sine 90 into n air. So if you have the critical angle, you can say glass refractive index of glass is 1 divided by sine C. Did you understand this? If you know the critical angle, you can calculate the refractive index very easy, right? Okay. Now let's say the interface was glass water one. Now the interface is glass water interface. That means you have glass here, you have water here. Okay. So here you get, let's say, angle C1 becomes 90. So you can say sine C, the incident angle into the into the refractive index of the incident medium in glass is equal to sine 90 into n water. So we can say n glass is equal to n water over sine C. So yeah, you can say like this. Uh, Here in this question, it might be another thing. From the earlier one, we have got ng into sine C1 is equal to this. Well, I explain this as well. So here I got something like uh, NW is equal to sine C2 into NG. Okay. I mean, it depends on the question, right? In this question, they have asked to find the refractive index of what, I guess, into Ng. So Ng I have found in an earlier practical that Ng is equal to 1 over sine C1. So I can replace that and get this equal. This is no big issue, right? If you do the past papers, you will meet this question. Like, uh, that is no big issue. You can, according to the question, you can complete that. You should know this concept, right? I mean, how to write the refractive index in terms of the critical angle. That thing you can do by applying Snell's law simply. And please remember the steps. That's it, right? If you remember the steps of this practical, that's done. You're done. And if you understand the concept properly, you are done. All right. Relatively to before page 1, yes, E2 is larger, so P2, P3 should move toward the right rather than PQ. Yeah, it's also another thing. Like if you, instead of using glass and AI interface, in this experiment, we have used glass AI interface. Here it is glass water interface. So when you use a glass water interface, the critical angle becomes larger. Therefore, since the critical angle becomes larger, the pins have moved a little bit to the right. Okay, the pins have moved a little bit to this side. Okay, these things I have written because they were asked in those in the past paper question. Right, that's why I wrote those points. They can be repeated. And the other thing is, if you understand, if you study this, you can get a very good idea about the practical. So study this using the question and answers. Okay, right. This is the end of critical angle practical.